All right, there we go. Banking angle. What the? All right. What is it? All right. I think that's it. All right, you can follow along with me on page 117 if you like. That's in the textbook. You can follow along with me on page 117. Right? So on this next test we're coming up with, right? On next Friday, we're gonna have the situations that I talked about from chapter 4, right? And those are the stationary box. Well, maybe let's write it over here so we can keep it on the recording. All right, so we got the stationary box. So this is so let's take that down. Let's take that. Y'all don't have to do what I do. All right, so for next Friday is what day? 7th, 11, 7, 25, test 2. And test 2 is stationary box. Box. Non-stationary box. Box down and inclined plane. Box up and inclined plane. Inclined plane. And the Atwood machine, right? And this last one is going to be banking angle of a highway. Of a highway. Of a highway. Or a road or whatever. I just say a highway, okay? So these are the situations that we're going to go over for, or we're going to cover to test 2. Right? We're only going to have four questions. So I'm going to pick one of these, or 4 of these. All right? So that's how we're going to increase the difficulty. Okay? So it's one of these, 1, 2, 3, 4, 5, 6 situations. 4 of these 6 situations for next Tuesday. Next Friday. All right, so we got that on the recording. Let's make sure we get that. Yeah, we got it. I don't know why. I need a video arts. But something ain't right here. I don't know what's going on. Why is my phone? Why is it doing this? I don't know, y'all. We're gonna have to do it the best we can, but it's doing something weird. Why can't it be getting? All right, so hopefully everybody wrote that down. And like I said, we got videos for all of those on Canvas. In every situation, we'll have a video for it on Canvas. All right. So again, we're on page 117. We're just going to go over this problem, the banking angle. Okay. All right? Example 5-7. Example 5-7, right? It says for a car traveling with a speed v around a curve of radius r, determine a formula for the angle at which a road should be banked so that no friction is required, right? What is the angle? Let's just deal with that A part, okay? Let's just deal with that A part. So it says determine a formula for the angle, right? So that's what we're looking for, all right? And so obviously we know that we are dealing with free body diagrams, okay? And we can draw a situation like this, okay? Well, we know this to be a triangle, right? And so we're gonna imagine that our vehicle is traveling on a plane perpendicular to the board. Y'all follow me what I'm saying? Meaning it's coming like this, right? Okay, so it's going in a circle like this. So it's on top of this right here. So you can imagine this is the highway, and you're coming around, like when you're coming around by the state capitol, right? And it banks a little bit. Okay, that's what you can imagine. Okay, so this is our, and I'm not a good artist, so bear with me on the car. But this is our car, okay? Whatever. Okay, that's our car. Now imagine our car is looking at us now. It's not going up the thing or coming down. It's coming out of the board. That's like a highway, right? How you would go around the highway, like that, right? So what we have to do now is we have to do a free body diagram, right? That's all. Okay, so this is another type of free body diagram. Only now we're on the box, right? Which is what we dealt with in chapter 4. Going up or going down. Now you're not going up or going down. You're just going around in a circle. Okay? But the free body diagram works the same. Okay? So you identify the forces. Right? So what are the forces? We got gravity, right? And this time I'll draw it from the, well, I don't want to cross those markers up. All right, so we got gravity, Fg, right? M times G, right? And we got a normal force, right? From our object sitting on that surface, right? And so, because we know that we are traveling in a circle, right? So the car is coming out and going into the board. So it's traveling on this plane, right? Out and into the board, right? Not on this, like this. It's going out and into the board, out and into the board, okay? And so, and we have an angle here for our inclined plane, right? That's that angle theta, okay? And so, instead of taking the projections of the force due to gravity, like we did with the box, we're going to take the projections of the normal force in this case. So that's what you need to remember from this. Yes, sir.
So are we using the normal force because the car is moving? Like
No. Just because it's on that surface. Remember, the normal force is anything that sits on the surface, you're going to have a normal force. All right? And so now we're going to take projections of the normal force, like we did when the box on the inclined plane, we took projections of the gravity. Now we're doing projections of the normal force. So that's this one, right? This is our normal force right here. So we take projections like this, right? And of course, we don't need to, I don't need to convince you that, just take my word for it, this is our theta, the same angle as here. Let's make it easy. We don't have to go through mathematics to prove it and all of that stuff. We're just gonna know that this theta right here is our theta right here. They normally give that to us in the problem. Okay? So then this projection is what? What is this one? Cosine. Fn cosine theta. And what is this one? Fn sine theta. Right? Yeah. So now, and we also know that since we're traveling in a circle, right? Then we know from Newton's laws that whenever an object travels in a circle, it accelerates towards the center of that circle. So the acceleration in this case is going this way, right? Because the circle is like this, right? In and out of the board. So the center of that circle is somewhere here, right? In and out of the board. Okay? So now we can draw our free body diagram. We drew our free body diagram. Now we can do what? What's the next step? Solve for what? Sum all the forces up. All right? Red. All right? So we sum forces. The same in chapter 4. Same deal. Free body diagram. We just got a different situation now. This is banking angle of a highway. So when engineering folks go out and do the highway, they make these kind of calculations. Banking angle of a highway. So we can know how much we need to bank so that we can prevent you from crashing out. All right. So now let's sum them up, right? In the x direction, what do we have? Huh? Remember the x? Remember this is our what? This is y. This is x. Fn sine theta in the x, right? And what is that? Is there anything that opposes Fn sine theta?
Nothing opposes it, but you can add acceleration.
No. That's close. You don't add it. You don't add it, but you do what? Equals. Now what? Now remember, our acceleration changed. When we're talking about going in the circle, it changed to what? That's in the notes, in the lecture notes. Right? Our acceleration changed to what? A is equal to what? V squared over R. So that's the only force acting in the X. So then that must equal to M times V squared over R. I just replaced A with V squared over R here. Now we sum on the Y. How we sum on the Y? Somebody tell me.
It's the
Fn cosine theta. Huh? Minus what?
minus FG.
Minus Fg equals
Should be
0. Yes, sir. You don't move in the y direction. All right. So now, right, we have two equations, right? And so we can rearrange this equation right here. So we can take our first equation, let's write it in a different color. We take our first equation here, right? And we can rearrange this for f of n, right? And we can say f of n is equal to what? I mean, not the first one, the second one, sorry. Second equation. Take this and rearrange this for f of n, right? Solve for f of n, the normal force, right? And I just bring this to that side. That means what? Therefore, f of n cosine theta is equal to f of g, right? And we know f of g is equal to what? mg. So then that means what? F of n cosine theta equals mg. And so we just divide both sides by cosine theta, and we get f of n equals mg divided by cosine theta. All right? Now that's for f of n, right? Now, we're going to take f of n and put it into equation 1. Right? So now we're going to take this file and we're going to replace it. We're going to put it here. Okay? So let's do that. Take this right here. Is this on the camera? No. Take this right here. Why is my camera acting like this? This is crazy to me. This is straight right here. I don't get it. Something weird. All right. So we take this and we replace it right here. All right. So we're gonna write mg cosine theta. So well, it's right here. We don't need to write it again. So we're gonna write what? Oh, right here, I'm sorry, in the equation 1. So we're gonna write mg cosine theta times sine theta, right? Equals mv squared over r, right? And what do we notice immediately? Well, yeah, you do. That's something, right? We have sine and cosine on the same side. Yep, so we can replace that with what? Sine over cosine is tangent. So this is mg times tan of theta equals mv squared r. Right? But we also notice that we have what? We have m on both sides. So let's get rid of the m's. M's cancel on both sides, right? So that leaves us with tan theta is equal to v squared over r. And so I'm sure that they told us how fast the car was moving.
We left off the G.
We left off the G where? Oh, yeah. So it'd be G, right? Did I need to do? Yep. Or G. Sorry about that. Good. That's what I like. I make mistakes all the time. Y'all should be catching me when I make mistakes. So now we got expression for tangent of theta, right? And so we already know how we get the angle from tan theta. We do what? Inverse tan theta. So inverse on your calculator, you just need to get this number, right? V squared divided by R times G, and then hit inverse tan of that number, and it should give you that angle. That's the angle that the highway must be banked on so that you don't crash out. Right? You don't need friction to hold you in place. So you don't need to, you can go around the curve without any other force. Like I say, when you go around the curve and you make that, right? That's friction. That's a friction. That's friction trying to hold you in place, in orbit. Right? So this is how we figure out how to avoid that situation from crashing out around the curve. Okay? So, hopefully, let's make sure this is all, everything is there. Yeah, like I say, I don't know, y'all. We got to figure out something out with these videos, because my phone ain't going to get it. I don't know what this is doing. It's crazy. Let me take it off of there. Now it's working. Now it's doing. I don't know what this thing doing. All right, so here. So hopefully y'all can see that. All right. Hopefully it's the beginning of it is pretty clear. But like I say, when y'all writing stuff down, though, you should be able to match it up. You know, if you get lost somewhere and go through the video, you should be able to match up what you wrote down. All right. So, any questions about that? So, do we have a value? This is example 5.7 in your book. Somebody give me the angle. I want you to calculate it though. Got it?
The angle?
Yeah.
Yeah, it's 22.
22 degrees. Right? 22 degrees sounds reasonable, right? What if it was 65? Then what would you say? Well, yeah, it would slide down. It would slide down, yes, right? But that's when the gravity would take over, right? Probably this right here would take over, right? It would take over this normal force if it was like that. Got it? All right, so hopefully that video is clear for y'all. I'm gonna stop it now.